Hello students, you're welcome to chemistry class. Today we'll look at question number 5, 6, 7 and 8. A basic postulate of the kinetic theory of gases is that the molecules of a gas move in straight lines between collisions. This implies that A. Collisions are perfectly elastic. B. Forces of repulsion exist. C. Forces of repulsion and attraction are in equilibrium and collision are inelastic. Before we pick the answer, let's look at the kinetic theory of gases. Let's assume we have gas molecules in this container. The first theory states that molecules of gases move randomly in straight line, colliding with one another or with each other and with the walls of the container. So that was the first theory. They collide with one another and with the walls of the container. They collide with one another and with the walls of the container. The second gas law says that the collision between gas molecules is perfectly elastic. The collisions are perfectly elastic. It means that when they collide, they separate and come back. They collide, they separate and come back. Okay, collisions are perfectly elastic. I think this is my answer. But let's look at other laws pertaining to the kinetic theory. Number 3 is that the volume occupied by the gas molecules in the container is negligible. That is small compared to the volume of the container. You can see the volume of the container, the volume occupied by the gas molecules, because the gases actually move randomly throughout the container. And another law states that number 4 or 5 states that the temperature is a measure of the average kinetic energy of the gases. It means that when you increase the temperature, what happens? The gases, they gain higher kinetic energy. So the answer is collisions are perfectly elastic. Let's look at number 6 question. On which of the following is the solubility of gaseous substance dependent? Nature of solvent, nature of solute, temperature and pressure. We have solubility of solids and we have solid/liquid, and we have solubility of gases. The solubility of solids depends on temperature. That is, the higher the temperature, the higher the solubility of solids, which are the solutes in solvents. Number 2, nature of solutes, and number 3 is nature of solvents. Don't forget that polar solvent dissolve polar solutes. That is why we have what is called polar dissolve polar, like dissolve like. So if the solute is polar and the solvent is also polar, they can dissolve in each other. But if one is polar and one is non-polar, they can't dissolve. Let's look at solubility of gases. Number 1 is a decrease in temperature, increase. Let's put the arrow here. A decrease in temperature increases the solubility of gases, because immediately you increase the temperature. Let's assume gases in this container. Immediately you increase the temperature, what happens? The molecules of the gases, they gain higher kinetic energy. Instead of dissolving, they try to escape, and when they escape, they dissolve less in the solvent. So that means if you need to increase the solubility, you have to decrease the temperature. And number 2 for gases is that the higher the pressure, increase in pressure increases solubility. The higher the pressure, the higher the solubility. Let's take a look at gases in a soft drink. Let's assume this is a soft drink. This is a bottle of a soft drink. A carbonated soft drink, for example, it contains CO2 gases. CO2 dissolved in a solvent. Immediately you open, they are dissolved with higher pressure in the container or in the bottle with higher pressure. immediately you release or you open this soft drink from the cork, what happens is that the pressure you have used to put the gases in the solvent in the container, the pressure actually decreases. What happens is that the CO2 can actually bubbles and escape to the atmosphere, leading to less solubility of the gases. So another factor that determines the solubility of gases is the nature of solvents. Organic solvents actually dissolve gases generally. So if I want to pick my answer here for solubility of gases, we have pressure, we have nature, we have temperature, and we have nature of solvent. That's 1, 3, and 4. So the answer here is 1, 3, and 4. The answer is D. Let's look at the next question. Which of the following statement is correct about periodic table? We've talked about the periodic table. The valence electrons of the elements in the same period increase progressively across the period. Yes, this is the answer. And we have to prove it. Don't forget that we have the periodic table like this: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. If you look at this period 1, period 2, period 3, and period 4, this group 1 to group 0 or group 8. Let's take a look at period 2, or let's take a look at period 3. Period 3 contains sodium. The electronic configuration of sodium is 2, 8, 1. It has one valence electron in the outermost shell. Let's look at that of magnesium, 2, 8, 2. It has 2 valence electron or outermost electron. Let's look at aluminium. Aluminium is 2, 8, 3, and so on like that. You can see that across the period, the valence electron increases from 1, 2, and 3 to 8. So the answer is the valence electrons of the elements in the same period. All these elements are in the same period. They increase progressively across the period. Number 8, the boiling of fats and aqueous caustic soda, which is sodium hydroxide, is referred to as A, hydrolysis, B, esterification, C, acidification, and D, saponification. The answer here is saponification. That's the process by which we produce soap. How do we produce soap? We react the boiling fat or oil, we react it with NaOH, that's the caustic alkali or soda, to give RCOONA, that's the soap, the formula for soap, plus propan 1, 2, 3 triol, or you call it glycerol. So these are to produce soap through the process of saponification. So the answer is here is D. This cannot be esterification, because when you talk about esterification, you're talking about the reaction of an alkanol with alkanoic acid to give ester, formula for ester here, or you call it alkanoate, and water. The reverse process is called hydrolysis. When you hydrolyze ester so that the ester can be split into 2, then you form back RCOOH and ROH. So the answer here is saponification. Thank you very much. We meet in the next class. Goodbye.